Welcome to our exploration of nanotechnology, a groundbreaking field that manipulates materials at the atomic and molecular scale. In this session, we'll uncover how nanotechnology is transforming society, analyze its impacts through science, technology, and society (STS) lenses, and critically examine its costs and benefits. By the end, you'll have a comprehensive understanding of both the potential and realized effects of nanotechnology, as well as the ethical and environmental considerations that come with its rapid development. Let's begin our journey into the world of the incredibly small, where big changes are happening. Nanotechnology refers to the science and engineering of manipulating matter at the nanometer scale, 1 nanometer being a billionth of a meter. At this level, we're dealing with atoms and molecules, which allows for the creation of new materials and devices with unique properties. These properties can be harnessed for a wide range of applications, from electronics to medicine. The ability to control matter at such a small scale opens up possibilities that were previously unimaginable, making nanotechnology a truly revolutionary field. Truly grasp nanotechnology, it's important to understand the nanoscale. The nanoscale ranges from 1 to 100 nanometers. For perspective, a single nanometer is 1 billionth of a meter. This scale is so small that it's invisible to the naked eye and even to most microscopes. At this level, materials often exhibit different physical and chemical properties compared to their larger-scale counterparts. These unique characteristics are what make nanotechnology so powerful and versatile. As technology advances, there are limits to how small we can make components using traditional methods. Nanotechnology offers a new approach, allowing us to process components and systems with nanometer-level precision. This downsizing doesn't just mean making things smaller. It means creating entirely new devices that operate based on the special properties of nano-sized substances. This leap in miniaturization is key to the next generation of technological innovation. One of the most exciting areas for nanotechnology is medicine. Nanomaterials are being used for advanced diagnostics, targeted drug delivery, and even cancer treatment. By interfacing nanomaterials with biological elements, scientists can create therapies that are more effective and less invasive. Terms like biomedical nanotechnology, bionanotechnology, and nanomedicine describe this rapidly growing field, which holds promise for revolutionizing healthcare as we know it. Diagnostics have been transformed by nanotechnology. For example, nanotechnology on a chip enables rapid and precise detection of diseases. Magnetic nanoparticles attached to antibodies can label specific cells or bacteria, while silver nanoparticles marked with DNA sequences can help identify genetic material. These innovations make diagnostics faster, more accurate, and more accessible, paving the way for earlier detection and better patient outcomes. Tissue engineering is another field benefiting from nanotechnology. By using nanomaterial-based scaffolds and growth factors, scientists can stimulate cell growth to repair or replace damaged tissues. This approach could eventually replace traditional treatments like organ transplants or artificial implants. Nanotechnology's role in tissue engineering is opening up new possibilities for regenerative medicine and improving patient recovery. Nanotechnology is making energy systems cleaner and more efficient. For example, nanoporous channels can filter pollutants from exhaust, and nanoscale catalysts can improve fuel efficiency. These advancements help reduce harmful emissions and contribute to cleaner air. Nanotechnology's role in energy is not just about efficiency, it's about creating a more sustainable future for everyone. The construction industry is also being transformed by nanotechnology. New materials and automated building processes allow for faster, safer, and more cost-effective construction. Nanotechnology enables the creation of advanced structures, from homes to skyscrapers, with improved durability and lower costs. This means better buildings for less money and with less environmental impact. Vehicle manufacturers are using nanotechnology to create lighter, stronger, and safer vehicles. Nanomaterials can withstand higher temperatures and are more durable, making engines and other parts more efficient. These improvements lead to vehicles that are not only faster and safer, but also more environmentally friendly due to reduced fuel consumption. Nanotechnology is making its way into our homes, too. Self-cleaning surfaces on ceramics and glass, as well as nanoceramic particles in household appliances, are making daily life easier. These innovations improve the durability and heat resistance of everyday items, such as irons and cookware, making them more convenient and longer-lasting. The textile industry is benefiting from nanotechnology through the use of engineered nanofibers. These fibers make clothes water and stain-repellent, wrinkle-free, and even protect against static electricity. Nanotechnology allows for garments that require less frequent washing and can be cleaned at lower temperatures, saving both time and energy. Nanotechnology is also making waves in cosmetics, especially sunscreens. Traditional chemical UV protection can be unstable over time, but mineral nanoparticles like titanium dioxide offer longer lasting and more effective sun protection. These advances are making skincare products safer and more reliable for everyday use. Nanotechnology has the potential to revolutionize agriculture and the food industry. From production to preservation, processing, packaging, and even waste treatment, nanotechnology can improve efficiency and safety. These innovations could reshape how food is grown, processed, and consumed, leading to better food security and sustainability. Nanotechnology offers significant benefits for the environment. It enables cleaner, more efficient industrial processes and helps detect and eliminate pollution in air, water, and soil. High-precision manufacturing reduces waste, while advanced solar cells provide clean, abundant energy. Nanotechnology can also help remove greenhouse gases and remediate environmental damage, contributing to a healthier planet. Graphene, a remarkable nanomaterial, is making a big impact on the environment. Graphene-based nanocomposites reduce the weight of airplanes, leading to significant fuel savings and lower emissions. Graphene thin films can replace metal meshes in aircraft, improving safety and efficiency. Its properties also enhance renewable energy processes, such as making wind turbine blades lighter and more effective. Despite its benefits, nanotechnology poses environmental risks that are not yet fully understood. High energy requirements for producing nanoparticles can increase energy demand. Toxic and persistent nanosubstances may cause environmental harm, and recycling rates for these materials are often low. The full life cycle impacts of nanotechnology need further study to ensure safety and sustainability. Our understanding of the environmental effects and risks of nanotechnology is still limited. There are gaps in knowledge about how nanoparticles behave throughout their life cycle, from production to disposal. This uncertainty makes it challenging to assess the true risks and develop effective regulations. Ongoing research is essential to close these gaps and ensure responsible development. The rise of nanotechnology is changing the workforce. Industries and educational institutions must adapt by updating curricula to focus on science, technology, and engineering. This shift ensures that workers are prepared for new roles and challenges. Public schools, community colleges, and universities all play a part in preparing the next generation for a nanotechnology-driven future. Advances in miniature electronics, driven by nanotechnology, are changing classrooms. New tools and devices make learning more interactive and effective. Organized education and training systems for college students and researchers are crucial for reducing the negative impacts of nanotechnology. By staying ahead of technological advances, education can help ensure safe and responsible use. Educational progress often follows research progress in nanotechnology. However, researchers and students may not fully understand how nanoparticles affect systems, partly due to a lack of toxicity information from manufacturers. Proper training and access to safety data are essential for minimizing risks and maximizing the benefits of nanotechnology in research and education. Nanotechnology is an advanced interdisciplinary field that combines science and technology to create materials with wide-ranging benefits. Its applications span healthcare, environment, energy, food, water, and agriculture. This interdisciplinary approach is key to solving complex problems and improving quality of life across society. Nanotechnology is a field that invites exploration, not just by experts but also by newcomers. Advancing our knowledge in this area is crucial for the progress of science and technology. By encouraging participation from a diverse range of people, we can unlock new discoveries and drive innovation that benefits everyone. Before fully embracing nanotechnology, it's important to consider the social, ethical, and environmental concerns associated with its use. These concerns include privacy, safety, and the potential for unintended consequences. Addressing these issues early on helps ensure that nanotechnology is developed and used responsibly, with benefits that outweigh the risks. Selecting the appropriate nanoscale materials is a key factor in the future direction of nanotechnology. The properties of these materials determine their suitability for different applications and their potential risks. Careful material selection, guided by engineering ethics, is essential for safe and effective use in commercial products. Defining engineering ethics is crucial before the widespread commercial use of nanotechnology. Ethical guidelines help ensure that new technologies are developed with consideration for public safety, environmental protection, and social responsibility. Establishing clear ethical standards supports sustainable and beneficial innovation. Risk assessment is a vital step in evaluating new nanomaterial-based applications. By carefully analyzing potential risks to the environment and human health, we can make informed decisions about the development and use of nanotechnology. Ongoing risk assessment ensures that benefits are maximized while minimizing potential harm. A full life cycle evaluation is necessary for all nanotechnology applications. This means assessing the impacts of a product from creation to disposal. By considering every stage, we can identify potential risks and develop strategies to address them, ensuring that nanotechnology remains safe and sustainable throughout its use. Nanotechnology's impact on society is profound. It has the potential to improve healthcare, energy, and the environment, but also raises questions about privacy, safety, and equity. By examining these impacts through the STS, science, technology, and society lens, we can better understand the broader implications and make choices that benefit everyone. Nanotechnology offers significant economic benefits. It can make manufacturing more efficient, reduce costs, and create new markets and job opportunities. By driving innovation, nanotechnology supports economic growth and helps industries stay competitive in a rapidly changing world. While nanotechnology brings many benefits, it also presents societal challenges. These include concerns about job displacement, unequal access to new technologies, and the potential for misuse. Addressing these challenges requires thoughtful policies and inclusive decision-making to ensure that the benefits of nanotechnology are shared by all. Sustainability is a key goal for nanotechnology. By developing materials and processes that minimize waste and energy use, nanotechnology can help create a more sustainable future. This focus on sustainability ensures that technological progress does not come at the expense of the environment. Raising public awareness about nanotechnology is essential. People need to understand both the benefits and risks to make informed choices and participate in discussions about its development. Education and transparent communication help build trust and support responsible innovation. Effective regulation is necessary to guide the safe development and use of nanotechnology. Regulatory frameworks should be based on the latest scientific knowledge and address potential risks without stifling innovation. Collaboration between governments, industry, and researchers is key to creating balanced and effective regulations. Nanotechnology is a global field, and international collaboration is essential for progress. Sharing knowledge, resources, and best practices helps accelerate innovation and address common challenges. Working together ensures that the benefits of nanotechnology are realized worldwide. The future of nanotechnology is full of promise. Ongoing research is expanding its applications and improving our understanding of its risks and benefits. By focusing on responsible development and ethical considerations, we can ensure that nanotechnology continues to improve lives and address global challenges. Education plays a critical role in the advancement of nanotechnology. By equipping students and researchers with the knowledge and skills they need, we can foster innovation and ensure safe practices. Lifelong learning and continuous training are essential as the field evolves. Industry is at the forefront of applying nanotechnology to real-world problems. By investing in research and development, companies can create innovative products and processes that benefit society. Collaboration with academia and government ensures that industry advances are aligned with public interests and safety standards. Governments play a vital role in supporting nanotechnology through funding, regulation, and public engagement. By setting standards and providing resources, governments help ensure that nanotechnology is developed safely and benefits society as a whole. Public policy must keep pace with technological advances to address emerging challenges. As nanotechnology advances, new ethical dilemmas will arise. These may involve privacy, safety, and the potential for unintended consequences. Addressing these dilemmas requires ongoing dialogue among scientists, policymakers, and the public to ensure that ethical considerations remain at the forefront of innovation. Continuous monitoring of risks is essential as new nanomaterials and applications are developed. This involves regular assessment of environmental, health, and safety impacts, as well as updating regulations and best practices. Proactive risk management helps prevent problems before they arise and builds public confidence in nanotechnology. Applying life cycle analysis in practice means looking at every stage of a nanotechnology product's existence, from raw material extraction to disposal. This comprehensive approach helps identify potential risks and opportunities for improvement, ensuring that products are safe, efficient, and environmentally friendly throughout their lifespan. Engaging the public in discussions about nanotechnology is crucial for its responsible development. Public input helps shape policies, identify concerns, and build trust. By fostering open dialogue, we can ensure that nanotechnology advances in ways that reflect the values and needs of society. In summary, nanotechnology is a powerful interdisciplinary field with the potential to transform society. Its applications span medicine, energy, environment, and beyond. However, realizing its full benefits requires careful consideration of ethical, social, and environmental issues. By staying informed, engaging in dialogue, and prioritizing responsible innovation, we can harness nanotechnology to improve our quality of life. As we look to the future, nanotechnology will continue to evolve and shape our world. Ongoing research, education, and collaboration are essential for maximizing its benefits and minimizing its risks. By working together, we can ensure that nanotechnology serves the greater good and helps build a better, more sustainable future for all.